All right, so today we're going to be talking about independent and dependent events, or what we call compound events. So a compound event means that there are two things happening. If it's an independent event, what that means is that the second event does not depend on the other. For instance, I have a dog and my age. Having a pet or having a dog does not depend on how old you are. Okay, they're completely separate events. Now, something that's dependent, the weather outside and the type of clothing I decide to wear. Those depend on each other. If it's only 3 degrees outside, I'm not going to wear a tank top, flip-flops, and shorts. Some of you might, but you probably shouldn't. So, again, an independent event, an event that has nothing to do with the other. Or there are dependent events, and those are events, affect the other, not replacing. For instance, when I say not replacing, what I really mean, what I'm really talking about is that when I say it's not replacing, so if I have 10 cards and I pull out one, and the probability of pulling that is 1 out of 10, the next time I pull one, it's 1 out of 9. And the reason for that is because it's not being replaced. So dependent events affect the other. For instance, an independent event also may be, independent event might be flipping a coin and rolling a die. They do not depend on each other. Or spinning a spinner and rolling a die. But the numbers that I pick out of a hat do depend on the first event, because if I pull 3 out the first time, there's 3 less numbers that are in the hat. And so that would change my denominator in this case. Remember that probability is always set up as a ratio or a fraction. So I'm going to go ahead and go through and do these first 4 with you. And then the ones at the bottom, what I want you to do is pause the video, do them yourself on your document. And then once you're done with that, go ahead and then play the video, and you'll be able to pause and check your answers. If you still have questions, remember you can always reach out to me, and I'm more than happy to help you. Just you need to ask. All right. So we're going to start here. So a standard die is rolled twice. Remember that a die is just a 6-sided number cube. So there are only 6 choices when we are rolling the die. And the first time that we roll it does not affect the second time we roll it, because we still have 6 chances each time that we roll. So when we talk about odd numbers, we have 1, 2, 3, 4, 5, and 6. So the odd numbers are 1, 3, and 5. So half of the time you can roll an odd number. 3 out of the 6 choices. And the second time you roll it, you can have the exact same amount of choices. And we are actually going to multiply these. And when you multiply with fractions, you do not get a common denominator. In this case, happens to be, but you don't have to. So 1 times 1 is 1, and 2 times 2 is 4. So the probability of rolling an odd number and then an odd number again is going to be 1/4 of the times. So I would have to do this trial 4 times in order to get that to happen. All right, so over here we have both perfect squares. So perfect squares are numbers that when you take the square root of them, they come out as a whole number. So the perfect squares that I'm going to address today would be 1, because the square root of 1 is 1, and the square root of 4 is 2. 2, 3, 5, and 6 do not work. So a perfect square, there's only 2 out of 6 choices. I'm going to divide that by 2 to simplify. So I get 1/3. Now each time it's 1/3. So when I multiply straight across, I get 1. 3 times 3, 9. So 1 out of 9 times I will get both perfect squares in the end. All right, so an even number, we know that there are only half of the numbers being even. So we have 1/2, sorry about that. And then less than 5. So numbers that are less than 5 are 1, 2, 3, and 4. So we have 4, 6. Now I could reduce 4, 6 before I multiply straight across, because it'd make it a little easier. But if you don't want to, you don't have to. So I'm showing you that way now. 1 times 4 is 4, and 2 times 6 is 12. Both of these are divisible by 4, so it can reduce to the probability or ratio or fraction of 1/3. All right, so now we have prime numbers. Okay, so prime numbers are 1, 2, 3, and 5, because 4 and 6 are divisible by other numbers than 1 in themselves. So we have 4 of those choices. So I'm going to reduce that by 2, so that'll give me 2/3. And then the number 6. Well, I only have 1 out of 6 choices for that. 2 times 1 is 2. 3 times 6 is 18. I can reduce this by 2, and that gives me 1/9. Remember, if I'm going too fast, you can obviously pause the video and start back over. You do not have to go at the pace that I'm going. I'm just doing this so that you don't have to focus on the video as long. All right. Our next one, letter E, it says the probability of the same number both times. Well, to get the same number both times, there's 1 in 6 chances the first time, and there's 1 in 6 chances the second time. Getting that exact same number. So 1 out of 6 and 1 out of 6. 1 times 1 is 1, and 6 times 6 is 36. So that'd be 36 times. All right, our last one here, letter F, at least 4 both times. So at least 4 means include 4, 5, and 6. So that is 3 out of 6, or 1/2, and 1/2. And we know that 1/2 times 1/2 is 1/4. We learned that earlier. All right, now we're going to look at our second example here. So our second example here says a coin is tossed, then a letter from the word Indianapolis is going to be selected at random. Find each probability. All right, so when we are finding each probability, a coin toss is 1 out of 2, meaning heads or tails, and then Indianapolis has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 letters in it. Okay, so we know that there are only heads or tails when we flip a coin, so that is 1/2, and the probability of getting a P. So there's only 1 P in Indianapolis, so 1 out of 12. 1 times 1 is 1, and 2 times 12 is 24. So we have 1/24. All right, so letter B here says tails. We know that's 1/2. And then a vowel. Vowel are A, E, I, O, and U. So we have 1, 2, 3, 4, 5, 6. So 6 out of 12, which reduces also to 1/2. If we divide by 6, we get 1/2. So 1/2 times 1/2, we've done this a lot already today. You should have gotten 1/4. All right, so for tails, again, 1/2 of the time. N, I'm going to erase those purple lines. There we go. Okay, so there are 1, 2 N's. So 2 out of 12, or 1/6. If you don't want to reduce until the end, that's fine. So we get 2/24, divide by 2, and you would get 1/12. I'm really sorry if you hear my dogs growling. They are fighting each other right now. So sorry about that. All right, so for heads, again, 1/2 of the times. And for a D or an I, so for a D or an I, there's 1, 2, 3, 4. So there are 4 out of 12 there. Some of you like to cross reduce, and you can do that as well. So 2 goes into 2 one time, 2 goes into 4 2 times. 1 times 2 is 2, and 1 times 12 is 12, so I get 2/12. And so I can still reduce that by 2, which will give me 1/6 as my answer. Alrighty, on to number 3. So number 3 here, it says the spinner below is spun. Then a month of the year is randomly selected. Find each probability. Okay, so it's spun and then a month of the year. So there are 12 months in the year. I'm going to go ahead and write those out real fast. So there's January, February, March, April, May, June, July, August, September, October, November, December. All right. So here we go. With letter A, it says at most 7. So the greatest we can have is 7. So there were 7 choices below that. So 1 through 7 out of 10. And then the month of February, 1 out of 12. So we will multiply straight across. 1 times 7 is 7, and 10 times 12 is 120. So 7 out of 120 times that we would pick a number greater than 7 in the month of February. All right, so here the probability of spinning a 4 is 1 out of 10. And then a month that starts with the letter J. Well, we have January, we have June, and we have July. So that is 3 out of 12. So we're going to multiply straight across. 1 times 3 is 3. 10 times 12 is 120. Both of these are divisible by 3. Oops. And that'll give us 1 out of 40. You also could have reduced 3/12 to 1/4 from the beginning, and that might have made a smaller number for you to deal with, and you can always do that. All right, letter C here, unshaded. So numbers that are unshaded, there are 6 out of 10. Okay, and then a month that starts with A. There is April and August, so that is 2/12. So what I'm going to do is I'm actually going to spread this out a little bit more, and I am going to reduce these ahead of time. There we go. All right, so if I divide this by 2, I get 3/5. And if I divide this by 2, I get 1/6. So I'm going to multiply 3/5. Let me change the color here. 3/5 times 1/6. 1 times 3 is 3, and 5 times 6 is 30. I divide by 3, and I get 1/10 as my solution. All right. And then for letter D, it says multiple of 3. So multiples of 3 are 3, 6, and 9. So there are 3 out of 10 choices there. And then a month with exactly 30 days. So January doesn't, February, March, April has exactly 30, June has exactly 30, September, and November. So we have 4 out of 12. Oops, sorry about that. So if I cross reduce here, 10 divided by 2 is going to give me 5. 4 divided by 2 is 2. When I divide by 3, it's 1. 12 by 3, it is going to give me 4. So then I multiply my 1 and my 2, which gives me 2. And 5 times 4 is 20. And then I can divide by 2, so I get 1/10 of the times. Alrighty. So here's my last example that I'm going to do with you. And then I'm going to explain number 5, and then we'll go on there. All right. Number 4 says it contains 8 green, 4 blue, 10 red, and 2 yellow. All right, so 8 plus 4 is 12, plus 10 is 22, plus 2 is 24. So we have 24 total. And the key is that it says it's replaced. So this means that it's an independent event. They do not depend on the other. So if I want to choose a red one, there are 10 out of 24, and I'll reduce that by 2. So that'll give me 5/12. And then the other one, being yellow, will be 2 out of 24, which again, I can reduce by 2. So that gives me 1/12. All right, so 5/12 times 1/12 is going to give me 1 times 5, 5. And 12 times 12 is 144. So 5 out of 144. Okay, so my next one here, letter B, probability of being blue. There are 4 out of 24. Sorry, divide by 4, and we get 1/6. And green ones, there are 8. So 8 out of 24. If I divide ahead of time, I divide by 3. Not by 3, by 8. There we go. I get 1/3. So 1/6 times 1/3 is going to give me 1/18. Okay. Then my next one here, if I have both blue, so we know that from part B, 4/24 is reduced to 1/6. So 1/6 being blue and another 6 being blue gives me 1 out of 36. And my last one, letter D, red. So there are 10 out of 24. And if I reduce that by 2, that gives me 5/12. So 5/12 times 5/12. Okay, so 5 times 5 is 25, and 12 times 12 is 144. So we have 25 over 144. Now remember, I said the remaining ones, numbers 5 through 10, I would like for you to try on your own. So go ahead and pause the video, work out the ones on your own. If you want at least help on number 5, I'm going to talk through it. I do already have it worked out, but if you want help through number 5, go ahead and then I'll pause it again. So on number 5, it is a little different, and the reason is because it says that this is not going to be replaced. So whenever it says not replaced, that means that your second fraction is going to be affected and changed. So if we did replace it, there were 40 total choices. So it'd be like 1/40 times 8/40. But in this case, because it's not replaced, if we look at part A here, it says that penny and then a dime. So there are 8 pennies, which reduces to 1/5. However, when you choose the dime, there are 18 dimes, but only 39 coins remaining because you did already choose 1 coin. So there is 1 less coin remaining. And we always assume that we chose whatever we wanted the first time. So in this case, a penny. So it doesn't affect the number of dimes. All right. So again, if you are looking at number 5, you can tell that each time my denominator changes on the second part. It becomes out of 39 instead of out of 40. If you want to go ahead and pause the video now, you can finish doing numbers 6, 7, 8, 9, and 10. And then you can check your answers. All right. So welcome back, everyone. I'm going to go ahead, I'm going to share all my answers with you. So I would recommend pausing numbers 5 through 6 right now. That way you can check your answers. And then go ahead and pause for numbers 7 through 10. All right, remember, if you are still not understanding how this is happening, please let me know. Tomorrow you're going to have more practice with independent and dependent events, and then we will continue learning probability. Hope you have a great day, and I'll talk to you later. Bye.